Okay, for part two, we have a couple slides here that have some properties of algebra that we've dealt with for a number of years now. I don't really think that you need to write all this down right now because all these properties are right in your book as well. But these are the properties that we've dealt with for several years in our math career so far. So point those out. We know that there's generally a pretty long list of properties here. We'll be using these throughout. A couple of things that we learned about in algebra we'll review right now. In this particular case, it's just an application of the distributive property. It asks us to take this and write it in expanded form. So remember, when we have anything in parentheses being added or subtracted, and we have a multiplier out in front or behind, doesn't really matter whether the x is on the right or the left of the parentheses. Okay, ultimately what we need to do is distribute, which is multiply the x by each of the terms inside. And from there, we should get x squared plus 3xy. And that would be the expanded form. And doing that backwards, we also learned in algebra about how to factor expressions to recognize that there's something in common between these two terms. And if we start with the numbers, we can see that 4 and 20, we know that 4 goes into both 4 and 20. So if we factor a 4 out, we also have a z squared and a z. And dealing with letters, we learned that we take out the smallest powered letter of the two that are there. And with that, we take our greatest common factor, which is 4z in this case, and if we divide both terms by 4z, we get what's left over in the parentheses. And so in this case, it'd be z plus 5. And remember, these factoring is checkable because we can just go backwards and redistribute that and make sure we get back to what we started with, which would be 4z squared and 20z. Okay. So a couple of algebra techniques using the properties that we learned that we'll practice on again today and then use throughout. Okay. Questions so far? All right. Let's see. A couple of different properties of additive inverses. Again, this table is in your book as well, so no need to really write all this down right now. Okay, just some reminders about negatives is what it boils down to. When we have something like this where we have the opposite of negative 3, that's how we read this. The opposite of negative 3 is, of course, 3. We have a positive times a negative. We know that we get a negative. Negative times a negative, which is a positive. And again, these are just illustrations of some properties of multiplication, addition that we know. If we have, in the bottom here, fifth property, if we have the opposite of 7 plus 9, okay, we can do the distributive property with that, and we can do negative 7 plus negative 9. Still get the result same way, negative 16 either way. Next, we're going to look at some exponential notation in this chapter, or in this section as well. Okay, we again remember from algebra that if we have repeated multiplication, something times itself more than one time, that we write that as a power instead. A couple of vocabulary words just to make sure that we're clear is that the n here is the exponent. Okay, a is the base. Okay, and so when we read this, we say a to the n is the nth power of a. Or if we read it also in English, we'd say a to the nth power. So again, we've had lots of experience with most of this stuff. Should be mostly a review for us at this point. Just going to practice some of the techniques that we learned. We also have a list of properties of exponents. Okay. And we'll look through the examples here. If we have 5 to the third times 5 to the fourth, remember, as long as the base is the same, we add the exponents in that situation. So we get 5 to the 7th overall. Same thing here. If we have x to the 9th over x to the 4th, if it's a division, we subtract the exponents. It's property number 2. And we'd ultimately get x to the 5th. Property 3 is anything to the 0 power. If we have anything to the 0 power, we'd get 1. Okay, if it was negative something to the 0 power, it would still be 1. If it was Christmas tree to the 0 power, it would still be 1. Okay. So whatever we raise to the 0 power, the answer is 1. We have a property for negative exponents. We deal with negative exponents by putting them on the bottom and making the exponent positive. Okay. Or if we had started out, the auxiliary to that would be if we started out with a negative exponent on the bottom, okay, we would change that to a positive exponent on the top, if you will. So if we have negative exponents, we just change the level, okay, either up or down. If it's down, it goes up. If it's up, it goes down. And then we change the power to a positive. Property 5 just tells us that if we have any expression in parentheses that we're raising to a power, that every part inside gets raised to that power. So a lot of times I would see on this problem people would write the answer as 2z to the 5th. Okay, if we just write 2z to the 5th, then we didn't account for the fact that the 2 needs to be raised to the 5th also. Okay, so that property would ultimately yield 32 z to the 5th. Number 6 is the power to a power property. If we have something to a power and we raise it to another power, instead of adding this time, we multiply. So again, just a review of the properties that we learned in algebra that we'll be using quite often. And finally, number 7 is just if we have a division of two things and we're raising that to a power, okay, we can rewrite it with both parts raised to that same power. Okay. So again, part of our work today, we're going to be practicing using our laws of exponents. So an example of that would be this one. If I have u squared over u to the negative 1, okay, if I just disregarded the v's for the time being, and I used my property, the property on the previous page told us that we would subtract these exponents, okay, to get an answer. And in the case of 2 minus negative 1, if I go 2 minus negative 1, that would be 3. So I'd get u to the 3rd. Okay? And then if I did that same thing with the v's, okay, I would get negative 3 minus 2, which would be negative 5. And one thing that we always want to do when we simplify expressions is not leave negative exponents. So the final answer here would be u cubed, and then the v to the 5th would go down on the bottom because it's got a negative exponent. We can make it positive by putting it on the other level. Okay. Questions so far? I also, just from the amount of practice that I've had with this, when I look at this expression, what I do generally, though, instead of taking this into two parts, okay, I generally just make another fraction bar. And if I look at these two, the u's, the u on the top has a higher power, so that means my u is going to be on the top, and it's a higher power by the difference, which is 3. I would have looked at the v's and saw that the v is bigger on the bottom, so that's where it's going to wind up if we want to keep our positive exponents. And how much bigger is 2 than negative 3? Again, the difference between those two would be what? 5. And so we can do that without having to go through that auxiliary step of getting the negative exponent. Okay? So this is the way I generally do it, but using the two properties, okay, we can do it that way as well. Okay. All right, next, the final part here today is dealing with scientific notation. So the last part of our assignment today is just practicing using scientific notation. And a couple of important points with that is that when we have scientific notation, we're going to have some number times 10 to some power. Key information, though, with that c, that number in front, it has to be a number that is greater than or equal to 1, but less than 10. So it can be 1 itself. Can't be 0.9 because that wouldn't be in this range. Okay, so it could be 1 or anything bigger than 1, but it can't be 10, and it has to be less than 10. So in other words, a single-digit number, if you will, okay, that's 1 or greater. Okay, that was what that c needs to look like. And then m has to be an integer, so it could be a positive whole number, okay, or it could be negative as well. And just to look at a couple of examples, what we're going to do today is convert something to scientific notation. And ultimately, our job is going to be to move the decimal place so that we get a number that's between 1 and 10. Greater than or equal to 1, less than 10. So if I move this over to that position, that would give me 3.45. That would qualify as a legitimate c. True? So if I go 3.45 times 10, and then the power, when I have a small number, okay, I got 1, 2, 3, 4, I moved it over 5 places. And to indicate that it's a small number, it needs to be to the negative 5. So 3.45 times 10 to the negative 5. So anytime it's a small number, something less than 1, okay, we're moving the decimal place to the right, and the power that we use should be negative and indicate how many places we moved it to get it to that position. Okay. Now, if we had seen this going backwards, okay, if this was the given information, we could change this to a decimal by doing exactly the opposite. We just take this decimal point and move it 3 to the, or 5, I should say, to the left. And recognize, again, as soon as you see the negative power, you should be thinking, oh, that's a small number. Okay, positive power, it's going to be a big number. Okay, so going backwards, changing from scientific notation to decimal notation. Okay, if we got 1.23 times 10 to the 5th, we should recognize that this is a big number or a small number? A big number because it's got a positive power. So I'm going to write 1, 2, 3. And remember, just to get it to the past the 2, 3, that took me 2 of the spots. Okay, but I'm going to go 5, so I need to go 1, 2, 3 more. So ultimately, that number in decimal notation is 123,000. Okay. So like I said, we're going to be doing some practicing with that. And that is the final slide. Okay. So for tomorrow,